Hi, in this video, we want to take a look at visualizing spatial data. All right, so much of this code is taken from the website for the textbook Applied Spatial Data Analysis with R. It's a good book. This is chapter 3. All right, so this chapter is very heavy on the SP package, which is not surprising. So our goal is to go through and visualize what we've got for our data. So my data is going to consist of, I've got coordinates, usually latitude and longitude, and then I have a data frame that connects to the locations, and I want to be able to plot and visualize what I see at each individual location. All right, so we're going to be using the MeUse data set quite a bit from the SP package, and to call that, I'm just going to go data and standard function. Now, after I get this, the data set does not have coordinates automatically set up. So to make sure that the SP package recognizes the columns X and Y as coordinates, what I'm going to do is I'm going to use the coordinates function to declare that. And so now, after I do that, the X and Y columns are going to be identified as the coordinates when I do my my spatial data analysis. All right, so the first example we want to look at is just plotting regular old points. So we're going to look at the simplest version possible. I got some points, I slap them down. Here I can see where was the data recorded for each location. Okay. And to do this, I just use the plot function. Now, if I install if I load using the library function or require the SP package, I do not need this double colon notation. But I recommend that you avoid loading packages if possible to prevent package confusion. And I feel like it's just good practice anyway to specify which package is working at any given time to make sure that unexpected results don't happen. All right, so now let's plot some spatial lines. All right, so for this one, what we're going to do is, so I'm going to take the coordinates object from MeUse, like we had previously, and I'm going to pass that into, so there's kind of a listed aspect of this. We're going to convert things into a spatial line. Now, to do that, I'm going to need to specify the lines, and when I do this with a list. All right, so I've got this outer list, which will be my lines list, and I'm going to use the SP lines function to figure out what's going on with these, to convert the points to lines, and then S line list. I'm just grabbing the coordinate points, and it's going to go through and it's going to play connect the dots with the points I have. All right, so now here it's just completely gibberish. It makes no sense to do this because the points were not along a continuous path. They were compared to this plot, it just scattered. There's no connection between location and the two-dimensional plane and location row on the data frame. So this is gibberish. This doesn't make any sense. But if I had data points that were supposed to be connected in a line, and I don't have it stored in a way that the SP package recognizes, this is how I convert that over. All right, next one we want to plot is our spatial polygons. All right, so what we're going to do is I'm going to take the MeUse river data set. I'm going to convert it to a polygon, and then I'm going to take so here I only have one polygon going, but I could have had multiple. I pass the multiple to the polygons function in the SP package. Then I put it in a list like that. And then I pass that list to spatial polygons. So this is very similar to what we did with the spatial lines, but now I'm doing with polygons. So I had to convert it to, so previously I converted it to a line, Then I put that output into a lines function, and then I plotted that. Here, I'm going convert it to a polygon. Then I take all my polygons and collect them together. Here, there's just one, so it's not very interesting. And then that list of polygons gets passed to the structure that I want to have, which is spatial polygons. Now notice that spatial polygons doesn't have a data frame connected with it. We'll get to that special case in a moment. And then I go through and I plot just like we do normally. And something that's nice is that the SP package figures out which version of the item is. When I have the right class set up, it figures it out and it plots it immediately for me. So here we can see the river. All right, so we can also plot spatial pixels. And so this runs very similar to what we've been doing so far. So I'm going to take the MeUse grid, I'm going to load that data set. I'm going to set up the coordinates just like I did previously in another code chunk. Now here I'm using the as function to convert my grid into spatial pixels. And then I just go ahead and I drop my spatial pixels object into image, and boom, it takes care of it for me. All right, so now we can see the grid over which the data was sampled from. All right, so let's keep working with spatial pixels, spatial polygons, and spatial points. All right, so here I want to bring it together. I want multiple things. I'm going to put down the grid first in the image. Then I'm going to add the river as a polygon. And then on top of that, I'm going to add the points where the data was sampled. And so now I can see pretty easily where the data was collected in relation to the river. All right, so now let's talk about controlling things a little bit more nuanced. So something that we're going to want to do if I'm doing professional visualizations, for a publication, maybe for a presentation, I'm going to show my boss something like that. Then I'm going to want to have more fine-tuned control over what's going on. So here I'm setting up my overall layout. It's a matrix with the numbers 1 and 2, and with 1 row, 2 columns. And then I'm going to plot the river, and then I can I'll plot the river also again. Here this axis equals false. Now here this will give me default axes. Here I don't have any axes, but then I go in and I tack it on manually. All right, side one is at the bottom low. Side 2 is going to be to the left side. All right, I don't know if my camera reflects the videos, but from my point of view, things are switched. But 2 is on the left-hand side, 3 is up top, horizontal, and then 4 is to the right. And so we can see that this determines which side I'm getting. This says where do I put my tick marks, and this is how big they are. So something that's nice about this axis function is if I want to, I could have different units on left and right, top and bottom. So I could have like feet on one side, meters on another. I could have Celsius and Fahrenheit on parallel axes. And so this gives me a good way of controlling things like that. And it's not really that useful here for spatial data, but conceptually, it's there. All right, so here's the default axes, and here's where I have more control. And you'll notice that the code, I didn't mention it, but the code shrinks down the size of the numbers. All right, now for controlling the margins, what I'm going to do is I'm going to use the par function for this. And so there are a lot of different margins in R. Usually MAR is good enough for most applications. There's also MI for internal margins, MAI. There's OMA for outer margins. There's several different ones, but usually MAR is good enough for most applications. All right, so what we're going to do is I'm just going to plot some stuff. So I've got the me used data sets, and I'm adding the river. Now I'm changing the margins, and I'm repeating my plots. So now let's see what happens. All right, so here, I've got everything is smaller. I've got my title, I've got my axes, which is good. But if I need to zoom in, this is set up better so I can see it. I'm taking full advantage of my plotting region with the one on the right. But I did that, I sacrificed some other information. But this is good because I have control over what's going on. Now, something we can do, we can also put a compass and we can put a scale on our map. So here I can go ahead and just plot, just like I have been, plotting the points, plotting the river. Now I repeat that, but this time I use the rescale function and I use the layout scale bar. What this is going to do, this is going to put down an indication of distance on my map. I can put down some text so I can see what's going on. Notice what's going on with the labels. And here I can put a north arrow on there so my reader knows which way north is. And you'll notice that we got 0 and 1 kilometer. And so the author went through and manually figured out these coordinates to be able to put these numbers right by the scale bar, which is kind of a pain in the neck, but it got spot on. It's looking good. All right, so another thing that we can do is start coloring our points by the data that we have. All right, so what I'm going to do, I'm going to take a spatial polygons data frame for North Carolina, and I'm going to visualize some SIDS data. But SIDS is very sad for each county. All right, so what I'm going to do, I'm going to read in my data using map tools. Now I'm going to make sure I have the projection that I want. So here I'm choosing datum NAD 27 for this one. So it's not the standard one that I usually use, but this is still a good one. Now here, what I'm doing is I'm doing some arithmetic to convert the number of SIDS cases divided by the number of births to give me the rate that's going on. So this way we're looking at the rate of SIDS instead of the number of SIDS. And now I'm going to color by quantiles. Or actually, this is, I'm coloring by quantiles, going from 0, then 0.2, 0.4, 0.6, 0.8, and 1. That's what the sequence does in the probs. Now I'm going to make it so that red represents, so SIDS is bad. So when I want to visualize something that's good, usually green is good, red is bad. It's a good schema. Yellow is in the middle because that that corresponds to traffic lights, and people pick up on that fast. All right, so what I'm going to do for each bin in here, I'm going to color it a different shade of red. The higher the SIDS rate, the darker it will be. And now I'm going to go ahead and plot it. So I'm going to take the SP package, and I'm going to just plot the spatial data frame. Now, when it comes to the color, I'm going to take that coloring that I just defined, and I'm going to go through, I'm going to say find interval for each of these. And it will work out which interval it's supposed to be in. And now here, something that's real nice to do is that I'm putting the degrees axes on here. And what this does, this puts down my latitude and longitude lines. And so here we can see pretty quickly that the dark red has a higher SIDS rate in 1974. All right, so something that is important when we work with our data is that I have to have the same projection for everything. So if I've got a polygon, I have a grid, I have some spatial points, I have to have everything on the same sheet of music. I have to have everything with the same projection. If I don't do that, I'm going to get gibberish. All right, so what we're going to do now, we're going to look at making sure that every single item I'm working with has the same projection. All right, so I'm going to go ahead and grab the map. I'm going to take the world map, the entire kit and caboodle. Now here it said we're going through and we're just trimming the map a little bit just to make sure that we don't have like excess on there. And now for my projection, I'm going to use the SpPackages CRS function to define the WGS84 projection as the one I want to use. Now what I'm going to do is I'm going to take that map that I have and I'm going to make sure that its spatial lines have the projection that I want. And over here, I'm going to take spatial lines world. All right, so this is going to be with the WGS84 projection. Down here, I'm going to take the same map information so I have up here, but I'm going to convert it to the Mulvida projection, All right, so here I went through and so I am defining this to be Mulvida projection. Now this is a projection that preserves area. And so this is a good choice when I want to have countries have the correct amount of area. Remember, there's always a distortion when I take a three-dimensional object surface and put it on a flat two-dimensional plane. So there's always a distortion when I'm using a map. Here, I get to control the way that it's distorted. Now, what I want to do, I want to go through, I want to get some grid lines going on. So I'm taking the WGS84 projection, and you know what? I want the latitude and longitude lines. So here, this is going from, this is going east and west, and this is going north and south. All right, well, this was built, the grid lines were built with the WGS84 projection. I want the Mulvida projection on this. So what I do is I take the output, I pass it to the transform function right here, and I just specify the projection that I want it to be. Easy peasy, lemon squeezy. Now, I want to put a grid on there, so it's a little bit more informative, more exciting map. So I'm going to go do that. So I'm going to use the grid at function to define a grid over my map. And now I want to have the same thing. I'm going to go ahead and just change it up using the SP transform to convert that to the Mulvida projection. All right, so now let's actually go through and plot the Mulvida projection map. All right, so I just go ahead and plot the whole thing overall with gray 60. Now I'm going to put the grid lines down. And after that, I'm going to go through and I'm going to put the coordinates on there. So what's happening is that the first one gave me the land masses, then the grid gave me the latitude and longitude lines, and then this text code gave the actual numbers along here. So that way I know what's going on.